Today's PortSwigger tutorial is entitled Web Shell Upload via Obfuscated File Extension. To solve the lab, we must exfiltrate the contents of the file /home/carlos/secret by using a basic PHP web shell. First, access the lab and log in as winner with the password Peter. The first part of this tutorial is going to be the same as with the previous tutorials from this series. We know that we are looking for a vulnerable image upload function, so let's first upload an avatar image. We are redirected to the /avatar page, and it looks like our image has been uploaded. When clicking the Back to My Account link, we can see that a preview of the image is now available inside of our account. Next, let's upload our basic PHP web shell. The code takes the value of the eval parameter from the URL and executes it on the server as a shell command. This time, we get an error. It looks like our file has not been uploaded because only JPEG and PNG files are allowed. Let's see how we can bypass this protection. Go to burp proxy HTTP history and look for the most recent /myaccount/avatar request. This is where we attempted to upload our PHP shell. Send the request to repeater. We also want to see the request that returns the contents of our uploaded image. For this, we need to go to the filter settings at the top of the requests list and click it. Here, we want to select images from the filter by MIME type section and click apply and close. We can now see a get request for file /avatars/your image name, in my case minion.png. As you can see, this request returns the contents of our image. Send this request to repeater as well. In repeater, go to the post /myaccount/avatar request. As you can see, if the file name's extension is JPEG or PNG, the file gets uploaded. If we try changing the file name's extension to something else, we get the error response from the server. It seems that the application has a mechanism to check if the file name ends with .jpeg or .png. Let's try bypassing this check by using some classic obfuscation techniques. For the purposes of this lab, I'm going to use this list of payloads from Payloads All the Things. This is by no means an exhaustive list, so you should create your own. I recommend combining this list with the examples given on the PortSwigger website as well as the ones found here on hacktricks.xyz. But for now, let's just copy this list from Payloads All the Things. Now go back to repeater and select the file extension .php. Send the request to intruder. In intruder, observe that the file extension has been placed between two payload markers. This is the position where our payloads will be inserted one by intruder. Make sure the attack type is set to sniper. Now go to the Payloads tab and paste the payloads we've copied from Payloads All the Things. We also don't want any URL encoding, so let's turn off the URL encode these characters option. Click Start Attack. Looking through the status code column, we can see that some of the requests receive a 200 OK response instead of 403 forbidden. Let's explore what might be happening here. When we use exploit.php %00.png, the %00 represents a null byte. As we've seen earlier, the application seems to have a mechanism to check if the file name ends with .jpeg or .png. This check might not account for null bytes. It sees that the file name still ends in .png, which means the file is considered safe and gets uploaded by the front end. However, in many programming languages, including C and older versions of PHP, a null byte is used to signify the end of a string. This means that when the server processes the file name, it will interpret the file name up to the null byte. So exploit.php %00.png is interpreted as exploit.php when the server-side code processes it. To check that the PHP file is also being processed by the server, let's go back to the request that returns the contents of our avatar file. Change the name of the file to your PHP web shell file, in my case exploit.php. After sending the request, we can see that we get a 200 OK response, which means that the file has indeed been uploaded. Also observe that the PHP code is not visible in the response, so the server might be executing it. If you remember from the beginning of this video, the PHP code takes the value of the eval parameter from the URL and executes it on the server as a shell command. This means that we need to add an eval query parameter to the path, so $eval equals followed by a system command, such as who am I. It looks like the current user is Carlos. Now we can simply exfiltrate the contents of the file we are interested in for solving the lab. cat/home/carlos/secret. We have found the secret. Copy it, go back to the lab and submit the answer. The lab is solved. This is it for today's tutorial. See you in the next one. Bye!